Our next speaker is Nicolas D'Ippolito from Asapp, our sponsor. So Nicolas received his PhD in software engineering from Imperial College London, and currently Dr. D'Ippolito is head of engineering at Asapp and a professor at Buenos Aires University. He has more than 10 years of experience as a researcher and more than 20 years of experience in the software industry. His research interest is at the intersection of AI for automated planning, game theory, and control theory. Join me in welcoming Nicolas.
Okay, so thank you for the lovely introduction. Today I want to talk to you about some of the things that we do at Asapp that make our life easier, our work easier, but we strongly believe that they could also make your work and life easier up to some extent. So, in order to tell you about what we do at Asapp, let me first start by telling you a story about customer care that I experienced in Montevideo yesterday. So this wasn't the original story that I had prepared, but it happened yesterday. So yesterday, Olivia, my oldest daughter, got sick. And we got to the hospital here, and they told us that without authorization from our healthcare insurance in Buenos Aires, they wouldn't treat her. So I called them, and they solved the issue right away, and within 5 minutes, Olivia was being treated. Although that didn't happen. I mean, it's not what happened. What happened was I spent 1 hour and 33 minutes on the phone. They didn't solve the issue. And Olivia was only treated 6 hours later. And in fact, if any of you was wondering where was I yesterday afternoon, now you know. I was trying to make my daughter was treated in the hospital. And this is the type of situations that we want to handle at Asapp. We want to improve the interactions between customers and companies. We want to make these interactions better for all the parties. And we do that by modeling these interactions and applying machine learning algorithms. So some of the metrics that we try to tackle are, with respect to clients, we want to make their experience much better. With respect to companies, we want them to put less effort and perhaps reduce costs in customer care. And with respect to customer care professionals, what we want is for them to be more performant, more efficient, and have a better work experience. By the way, we call customer care professionals agents. I know it's not the best term for this community, but this is how our customers call them. Now, so the way we approach this issue, this problem, is by trying to improve the capabilities of the agents. So we want to take humans that are taking care of all of us when we call our companies or institutions and make them more efficient. We do that by augmenting their capabilities using machine learning. So let me start with a brief example of one of the things that we do to help them. So imagine that you have a conversation, so you call your cable company, phone company, whatever, and you have a conversation with an agent, and Asapp, what we try to do is we try to sort of help the agent with potential answers that they can give us. So they don't need to write, they don't need to think much about it. We propose potential answers, and they simply choose among a set of those. The idea here is that we can apply, this fits very well in text generation, right? And a number of speakers talk about this week, and they better explain these topics over the talks that we had. However, one of the things that we could apply, and is much simpler than most of the things that we've seen this week, is rule-based approaches. So rule-based approaches are very good because they're very simple to implement. So you simply come up with a set of rules, conditions, and answers for each condition. You evaluate the context of the rule, and if the context matches, if the conversation matches the context of the rule, then you have an answer. They provide a baseline. If you have nothing, you have a baseline if you apply one of these techniques. However, I mean, they do have a low market time, and for us, this is very important because we do ship features to our clients. So our clients need our features to improve their efficiency in customer care. So obviously, rule-based systems are a bit limited. One of the things that you see is that they have a lot of corner cases, lots of things that no rules will match, and then you end up with answers that are very general or not that useful to clients. Also, the answers that you have are very monotone and predictable. They seem to be boring to the user. So these models are amazing. However, for the user experience, they're not great. Now, moving naturally to the next level would be to go for generative models. And we've seen a number of those this week. They obviously generalize more, right? So they generalize better, and they allow us to have answers for any variable input. So imagine that our inputs are full conversations, right? So for any conversation we have, this type of model will give us an answer. However, they seem to be very unpredictable to us. And in fact, and we also seen this in one of our talks, but as conversations length grows, they tend to degenerate fast and start giving meaningless answers. And more dangerously for customers, because they're more unpredictable, they could even give us racist answers or even politically incorrect answers. So this is very dangerous for our clients. And so what we do is we have an approach that combines the two, which are retrieval models. We believe these are the best of both worlds because we can handle variable input conversations, but we have control of the answers we give. So we can curate those answers to be fluent and to be useful for the customer. Now, it also fits very well our approach of having the human in the loop, because, for example, what we can do is, let's say that tomorrow we have, I don't know, the Super Bowl, or to bring an example that is closer to the Rio de la Plata, let's say that we have River Boca playing this week. And so our agents, our customers, are able to extend the list of potential responses that they can have. And they can include them in the system without retraining the model. And so that's an excellent feature for our customers as well. Obviously, the answers properties are guaranteed. And also, the way we evaluate performance of our model is closer to that of classification models instead of text generation models. And that gives us the advantages of the metrics that we can use in classification. And finally, and I think not more importantly, but very central to our work, is that with retrieval models, we came up with a solution that has very nice software engineering properties, quality attributes of the system. And this is something that we work a lot. We do not only do machine learning research and artificial intelligence research in general, but also we're very much concerned in software engineering and how we ship our models faster, better, and also how we can roll back them faster and better as well. It depends, right? So the implementation we have allow us to have this software engineering and essentially quality attribute that are central to our work. Now, this is our ranking model, the ranking model we use for this problem, for generating these answers. And most of these components have been explained, much better explained this week by other speakers. However, there are a few interesting characteristics that make this architecture not only novel, but also key to our online performance. And when I mean performance here, I mean performance in real time. I mean how fast we can infer these answers at runtime, not only the typical metrics that we use in machine learning. Now, among these characteristics, one of those is that our solution is inspired in Siamese RNNs that allow us to decouple the computation of the encoding for the context of the conversations from the computation of the encoding of the actual responses. And this is central to a solution, and you'll see that in the next slide. We also used, instead of using standard LSTMs, we use an Asapp variation of those called SRUs. If you want to read more about SRUs, you have the paper here. But the idea there is that by using SRUs, we can train our models much faster. In particular, we can train our models both at inference time and training time 4x faster than by using standard SLTMs. Now, we also use Facebook fast text, but we take the pre-trained model with English and we fine-tune it with our own data set of 15 million conversations in order to contextualize the model for the particular language of customer care. And finally, we use self-attention model, multi-headed self-attention models, in order to reduce the complexity of parameters that depend on the length of sentences and conversations as well. So, moving to inference time, because we have a predefined set of potential answers, we can pre-compute the encoding for all of those. And then, by simple, an inference time, we will get a sentence or a conversation. We can encode that conversation, and by simply that product, we can rank the potential answers, and we can send a relevant subset of those to the agent. This is also, I'm sorry, something else is that fast text is particularly good for us because in customer care domain, there's lots of misspells and lots of new words because you have a number of different clients and a number of different agents, and they're interacting in a very, I mean, normally clients, we're very sloppy. We want our problems to be solved, but we don't care really for how well we write or how well we speak in the conversation many times. And so we found out that fast text is central to us because the type of language that we handle is, I would say, is sort of sloppy in a way. So this is one of the things that we do. This architecture and also SRUs are both open source, publicly available. I left some reference in the presentation and also some QRs so you can scan them. But this is not everything we do. We also do, I mean, on top of this, we are concerned on how fast we can work. And let me go walk you through a couple of questions that I think they have a rhetorical nature, but let's see how it goes. So let's say that you have to do an LP task, and you spend 10% of your time like designing your architecture, your model, and then you spend 90% of your time setting up the cloud infrastructure, running your experiments, and only then you get to collect all your data and analyze it in order, for example, to figure out which are your best meta parameters for the problem. How many times you felt that way? Raise your hands if you felt it that way more than 2. Good. It's rhetorical, but I wanted to see some hands. Anyways, so once you have that, now there's another problem, which is coupling. How many times you had your model running, but now you want to reuse some of it, and it's impossible because it's all coupled within the architecture. I want to ask you to raise your hands because I know the answer already. And also, what about reproducibility of experiments? You publish a paper and you want your reviewers to be able to reproduce the paper. Or any experiment that you've done, I want to simply reproduce those experiments. What do you do? So you need to, I mean, there are a couple of things, a couple of solutions out there, but we couldn't find any of those that solve all these 3 problems. So because we do machine learning and because we do software engineering, we decided to simply develop our own open source framework on top of PyTorch but basically, very generally allows you to use configuration files, in particular YAML files, to configure the model you want to train, your data set, the metaparameters you want to explore, how you want to optimize your models, and all the variables and all the components you may want about this issue. And I think this is a very important thing. First of all, this is open source, and I mean, you can download it and you can play with it. But in fact, this is part of what we do at Asapp. We do machine learning research, but we combine it, and we have a very interesting synergy with engineering, with software engineering. We do not work separately, and I think this is related to Shapiro's talk on Monday. So we don't have the handoff event where machine learning researchers build a model and they send an email or whatever with the model to the engineers, and then the engineers need to work on endless hours in order to make that performant. We work together, so whenever we need to change something in the model to make it more performant, to make it work better at runtime, we are there together, improving it in a sort of virtuous cycle. Now, any further questions that you may have about Flambé, please check out our poster today. In the poster session later today. Before was like 2-3 hours later. Now I'm not sure, but it's later today. So, how on schedule? Yeah. How do we do this? We do this by having interdisciplinary teams. All our teams, or most of our teams, have product owners, because the driver of our research and the driver of our engineering is the product. Is actual needs of real agents down there serving customers. So we do have researchers and engineers working together in the same teams. And then we have also machine learning engineers, data scientists. I mean, I like to think of us as full stack in the sense of not front-end and back-end, but in the sense that we have all the roles that are needed in projects, we have them all working together. So this is how we structure our projects and our teams, and this is essentially the type of groups that we build in Asapp Buenos Aires. So we do have all the potential roles that we may need in a project in our Buenos Aires office. So we do machine learning research in Latin America, and particularly like the other side of the river. There is a river there? I think it's there. I think it's down, more or less down there. And we do have research projects that bring value to the product in Buenos Aires. If you want to know more about our research projects, I think you have a couple of our researchers and engineers here wandering around that you can talk to them, or you can talk to me as well. And essentially, the type of hiring we do is hiring in all layers, in all roles, and we do research here. And I think maybe you missed this in the introduction, but I'm head of engineering, but I'm also a PhD, and I've been a researcher for 10 years. So our focus is mixed. We always have this mixture between research and engineering, and I think that's a very interesting thing to have. And so if you have any further questions, we'll be there in our booth or in the poster session. So that's all I had to say. Thank you very much for this.
Thank you, Nicolas, for this fantastic talk. And thank you for sponsoring this event as well.
worries.
And we have time for one quick question, but Nicolas is around if you have more questions. Are there any questions from the audience? Yeah.
So you talked that you use retrieval-based methods in order to select suggestions for your agents. So how do you deal with the context dependence that you have? So do you hear me? Or,
Yeah.
Because
Yeah.
So for instance, because you can control what your agent says, but you cannot control what the client says. So
Yeah.
if the client asks, "Are you a racist?" then the system, can unfortunately select the answer yes, for instance, because yes is not a harmful word on itself, and it may be in your data set, I don't know, from which you select from.
Okay, so that's an interesting question, and I think It has many, many answers. I'm not sure I'll give you the best, but the questions that we select and the questions that we have in our model we're lucky enough that we have an amazingly huge database of previous conversations. So essentially, we do have all the context that we need because we have a huge history of conversations. And the type of sentences that we select come from that database. And then when we train our models already know those answers. So we simply then give those answers in different contexts because we train our models with those. And so the context, I think, comes from the fact that we have a huge database with full conversations.
Okay.
I'm not sure if I answered your question or if you have any further. But.
Well, I mean, I guess you may have very different combination of contexts, right? And it may happen that you reach one of these situations, but also you have your agent filtering the answer. I mean, you don't give it directly to the client, right? So,
no.
So there you have a filter that is very important.
Yeah, and
a
also,
human filter.
And also, we learn from them as well.
Okay.
And a very interesting problem we're facing now is because we're augmenting humans working, we wonder which agents should we learn from? Should we learn from the more trained agents, from the average agent? And can we do better than any of those? Can we simply raise the bar for all our agents, the best? I mean, the more trained and the less trained? That's one of the challenges we're working right now. So how we select the people and the agents that we want to learn from, and how do we improve them even further?
Yeah, and what question to ask to your agent, like this answer is offensive, for instance, and they can tag it.
Yeah, I mean, that wouldn't happen because we create the answers. I mean, although
But in this context, right? No,
but that's something that is sort of fun because when you do research, you want to solve the most general problem that you can find, and write the theorem that takes all of it. But in our case, we're solving real people's problem, and so we can. It's a fair thing to do to give it some context and to solve that actual problem.
Mm-hmm.
Well, we
can continue.
Okay. Thank you so much for that presentation. And thanks to our sponsors, DeepMind and ASAPP, for really making Khipu possible.